Right, so here's two bits. Okay, now a bit can either be a 0 or a 1, and then with these you can just have different combinations. So two zeros, then a 0, 1. You could then have 1, 0, and then a 1, 1. Okay, so with 2 bits you can have 4 different combinations. Now each combination can either represent a different colour, a different letter, or a different decimal number. So here's a 4 combinations here. Okay, so that's 4 combinations. Now if we then look at 3 bits, okay, and again each combination can represent a different colour. So that might be all black, this might be all white. Okay, so each unique combination can be a different colour, different letter, or a different decimal number. Okay. And again, using 3 bits, this is the number of combinations, and if you count it, there's 8 different combinations. Now, if we start getting more and more bits, okay, you'd have to count out every single combination, because if we ended up having something like 4 bits, well, you can see they're all 4 zeros all the way to 4 ones. There's 16 different combinations. There's 16. Now, there's a shortcut, okay, so the easy way of doing this, I'll show you in the first one, is we say the number of bits we're going to use is n, okay, so we say n equals 2, okay, and the number of combinations is 2 to the power of n, okay, so for this example, that's 2 to the power of 2, and that equals 4, okay, so that's the number of unique colours you could have, the number of unique characters, or the number of unique decimal numbers you could have. Okay, now when it comes to 0, 1, 2, 3 in decimal, there's 4 separate numbers. Now when it comes to actually identifying what's the largest positive integer, well, you're having to count 0, so this is where the wee formula 2 to the power n minus 1, so that would be 2 to the power of 2, which is 4, minus 1 equals 3. Okay, so this actually tells you the maximum number that you can actually represent using 2 bits, and this tells you the overall total number of unique numbers you can actually represent. Okay, look at this example. Okay, so n equals 3 because we're using 3 bits. So again, the number of unique combinations is 2 to the power of 3, which gives you your 8. However, if we actually count, so there's 1 to 8, but we have to start at 0. Okay, so there's 8 unique numbers, but if it starts at 0, then this number is 2 to the power of n minus 1, okay, which gives you your 7. Okay, so this is just to calculate the largest positive integer you can get, okay, when we have a certain combination. And if you look at the very final one, okay, we're using 4 bits, so n equals 4. So if you want to calculate, well, how many unique combinations, then you just put 2 to the power of n, we know that n equals 4, so 2 to the power of 4, that equals 16, okay. Again, that number's not 16 because we need to take account that we're actually not starting counting at 1, we're just going to start counting at 0. So if we did from 0 and counted all the way to 15, that's where we get these 16 unique numbers. But to calculate what the largest positive integer is, again it's 2 to the power of n minus 1, that's 2 to the power of 4 minus 1, and that's 16 minus 1, which gives you 15. Okay, so this just tells you the number of unique combinations, and this just tells you, well, what's the maximum positive integer that you can get out of using this combination. What you'll probably find is when they start asking you maybe to use 16 bits, then what you'll find is 2 to the power of 16, again, you'll get used to actually, you'll recognise the numbers, that gives you the answers, 2 to the power of 16, that gives you a possibility. Imagine it was colours, that would give you that many unique colours. It also gives you that many unique decimal numbers. But if we're starting at 0, then it has to be 0 to, just like we calculated this, 2 to the power n, then it would have to be 0 to this minus 1, okay? So that's what would be the highest number is just 65535, okay? So if you count from there to there, that actually is this amount number of unique numbers. And the very last one, true colour, but that's when you have 24 bits. So 2 to the power of 24. Again, you'll see this, and 2 to the power of 24 is something in which that's the highest that you'll really be asked to do. Okay, so that's a number of combinations that you'd have, but obviously if we want to find the largest number that you could actually use using 24, then you have to subtract 1 from it, because we're always starting at 0, and 0 is as much a number as any other one, so it'll be 0 to 2 to the power of n minus 1.